It's a okay, so for our anniversary, my boyfriend took me hiking in the mountains. My boyfriend proposed to me. They should call you Mario because you just got one upped.
You should have applied cool.
Okay, got it? All right, so let's do some review. Prerequisite, you need to know what a linear equation is. What is a linear equation? An equation looks like a line. Yes, it does look like a line. What specific property, when we look at equation, do you know it's linear? Degree of 1. Remember, the powers of the exponents should be all 1. So a linear equation is an equation of degree 1. Often in the form y equals mx plus b. Now the unit is called linear system, so you need to know what a linear equation is before we can talk about what a linear system is. I put in this table here because in this unit we're going to have to translate word problems into equations. And that's probably the toughest part of this entire unit. We'll get really good at solving them, and I'll talk about today what that means to solve a system. But one of the most challenging things is, of course, taking word problems and making equations. And so with enough practice, we should get really good at it. Equal to, often the most common word you might see is. The length is 5 less than the width. Addition, we often use more than or less than. That's why I put them in bold. Division doesn't often come up. Multiplication of is a common one. Or triple or 3 times or half, right? That's when we're going to use multiplication. And then, of course, our unknown number is always a variable. So this is just kind of a beginning place. You might want to go online and get a larger chart to help you. But we are going to deal with changing words into equations. Okay, so a system of equations. I'm just going to come out and tell you what a system of equations is because you probably don't know what it is. Unless anyone wants to take a random guess. Okay. Yes, more than one equation working together. So, in more mathematical terms, 2 or more equations with 2 or more variables. And usually the case is the number of equations and the number of variables are usually the same. Usually, the number of equations equals the number of variables. Usually the number of equations equals the number of variables. So if we have 2 equations, we're going to have 2 variables. Usually 3 equations, 3 variables. Now we're going to only deal with 2 equations with 2 variables because we're dealing with linear systems. And linear systems are of mostly x and y, right? Degree 1, x and y. So an example of a system of equations would be like this. 1/2 x plus 5y equals 12. And let's say y equals 2x plus 3. Okay, together, these 2 equations with 2 variables. Now, one of the equations could only have 1 variable. As long as overall we have at least 2 variables and we have 2 equations, that's a system. That is a system, right? And whenever we have any type of system, it's when 2 or more things are working together, right? We have the system in your body, organs and the tissues. Right? Anytime we have a system, and you need more than one thing to make a system. Yes. They do have to be the same variables. It's a really good question. They have to be the same variables. If one equation was with x and y, and the other one was z and w, they don't relate then. They need to relate to each other. Now, one of the equations could only have one variable, because that would just be a vertical or a horizontal line, and that's okay. So when we have two lines, what do you think is the most interesting part about two lines? What will happen if we have two lines being drawn? Eventually, they're going to intersect unless they're parallel. And so in a system, if we have two lines, what we're actually solving for when it asks for the solution is going to be the intersection point. It's the x comma y that's on both lines that satisfies both equations. It's the one point that they share in common. The point in common. And so whenever you see solve this system, really you need to interpret that as find the intersection point. That's the only thing that's really of value to look at with two lines. I don't know what else would be of value to look at. The most interesting thing is where do they intersect? So what if we have one equation with one variable? Well, that's like grade, I don't know, was that 8? 7? What do we do with that when we were solving? Move the 2. So how do we move the 2? Subtract 2. We're left with 2x equals 12, and then divide by 2. So when we had one variable, we always isolated that variable. X equals 6. So how many solutions would you get in an equation with one variable? There's always one solution. All right. You do not have this one. Take that out. Okay, so we want to find, sorry, did I miss something? Oh, yeah, I did. Okay, there it is. Linear equation with 2 or more variables. I need to take this off. Example, x plus y equals 6. How many solutions is that going to have? Can you give me a solution? Give me an x and y that adds to 6. 3 and 3. Okay, 3 plus 3 equals 6, so that would be the point. 3 comma 3. Pardon me? 4 and 2? I thought I heard not 4 and 2. What else would add to 6? 9 and negative 3. That's good. Okay, so how long could we go on for this? Forever. So if we have one equation with two variables or more, it's going to have infinite solutions. And those infinite solutions become our line. They become the line. Right? When we join all those solutions together, we get a line. Everything on that line is a solution to that equation. Make sense? Kind of? Maybe. It's warm in here. All right, don't change it, I won't. Okay, next example. So which of the following is a solution to the system? So what's a solution again? Intersection point. So how do I check if 1 and 8 is an intersection point with both those equations? Plug it in. If we plug it in, it should actually be on the line. So let's start with A, 1 and 8, and we're going to plug it into both equations. So we plug it in. If it's on the line, it's going to satisfy. It's going to be true. So the first equation is y equals 3x plus 5. So let's plug in our x and our y. Who's the y? 8 equals 3 times 1 plus 5, is that true? 8 equals 8, that's true. So we can say 1 and 8 is on the first line. It's on that line. It's a point that works. Let's try the other equation. 6x minus 5y equals negative 43. So we're going to plug it in and see if it's a point on that graph too. 6 times 1 minus 5 times 8 equals negative 43. When you plug that in, Jordan, what did you get in your calculator? It gave you negative 34. So is negative 34 equal to negative 43? No, it's not equal. Oops. Oops. Sorry, guys. I want the undo. There you go. Not equal to. Okay, so we put a not equal to. So is that our solution? No, that's not our intersection point. It's on one of the lines, but not on both. So let's try the next point, negative 5 and 3. Alrighty. Negative 5 and 3. Try the first equation. Y equals 3x plus 5. So what's our y? 3 should equal to 3 times negative 5 plus 5. What is 3 times negative 5 plus 5? Did anyone plug that in or figure it out in their head? Negative 10. Is that true? No. So that point is not on that line. So that can't be our intersection point if it's not even on that line. Let's try the last one. Is it? Okay, 2 and 11. So the first equation, 11 should equal to 3 times 2 plus 5. Is that equal to 11? Is 3 times 2 plus 5? 3 times 2. 6 plus 5 is 11. Yeah, that's true. So it's on that line. Let's check if it's on the other line. 6x, so x is 2, minus 5 times 11 should equal negative 43. We have 12 minus 55. Is 12 minus 55 equal negative 43? Yes. So if it's a point on both lines, is it our solution, the intersection point? Yeah, so 211 is the solution to the system. That's the point that they intersect at. That's the point that's on both lines. There's only going to be ever one point in common as long as we're dealing with two lines. Next year, you'll get bold, and they'll be like quadratics, and then you'll find their intersection points. There'll be more than one. With lines, there's only one intersection point. Yeah? Can you wait till after the lesson? Okay. All right, so it satisfies both, therefore is the solution. It is the solution. Okay, next equation. Next question, let's just talk about the solving systems, how our unit's going to look like. And so solving a system is finding the intersection, and there's more than one way to find the intersection. One is graphically. So we're going to spend day 2 and 3 solving graphically. So day 2 will be like using our y-intercept and our slope, plotting the two lines, and then from there coming to our intersection point. Day 3 is going to be using your graphing calculator. So you will have to have your graphing calculator that day because we're going to learn how to actually use our calculator to find it, which is great when our answer is a decimal and not a whole number. Algebraically is really important. You're going to need those skills also for grade 11 and 12. And so that's going to be day 4 and 5. Day 4 and 5. And then day 6 is just going to be looking at when we have parallel lines or the same line, so infinite solutions. And day 7 would be then word problems. And there's no day 8. No. And that's it. So by next Tuesday, we'll be done our last lesson in Math 10C. It's crazy. You thought this day would never come. It's coming faster than you realize. Okay, so let's look at this example here. The perimeter of a sheet of paper is 38 inches. The length is 3 inches more than its width. Create a linear system to model this situation. So when we make a system, we want two equations, and in each equation we want two variables. So the first thing we want to do is, what are the two unknowns? What are we looking for? What is the obvious thing that we don't know? So let's read through this again. The perimeter of a sheet of paper is 38 inches. The length is 3 inches more than its width. So what are our two things that we're probably looking for? Length and width. So choose two variables. Can we use L and W? It's just so obvious, you know? L and W. So L would be the length. W would be the width. No, that would not be good for my brain. When we make a system, so we want two equations, and each equation has to have L and W in it. Most of the time, each sentence is its own equation. So I have one sentence and then two sentences. So they're going to each be their own equation with L and W. So the question is, for the first sentence, the perimeter is 38 inches. How can L and W be related to 38 inches, to the perimeter? 2L plus 2W. Remember the formula, it's on your formula sheet. 2L plus 2W equals your perimeter of 38. So that's the first equation. That's on your formula sheet. You should probably know that equation by heart by now. It's one of those basic ones. Oh, I'm dying. Okay, second equation. The length is 3 more inches than its width. Now let's break this down. What's the length? What do we choose to represent the length? L. Move this. Uh-oh. No. Just erase the 2. The L is our length. Does anyone remember what is stands for in that chart? Equal to. The length is equal to. Okay? 3 more than. What is more than? Addition. 3 more than its width. How would I write 3 more than its width? Width is W. W, so length equals W plus 3. We always put the variable first and then the plus 3. If it was less than, it would be W minus 3. 3 less than the width would be W minus 3. Okay, so there's our two equations. Notice each equation has both variables in it, and we have two equations. So that is a system. Two equations, two variables. The paper to be 11 by 8. So in today's homework, we'll make some equations, and they'll give us the solution, and we're just going to practice verifying the solution. So if a paper is 11 by 8, which one's the length and which one's the width? Length is the long side, 11, and width is the short side, 8. So we're going to verify, so do a check. So in order to check, we'll take both equations. We have to plug in our solution, and left side has to equal right side. Okay, it's kind of like doing a proof. Left side has to equal right side. So 2 times our length is 11 plus 2 times our width of 8 has to equal 38. 22 plus 16 is 38. So 38 equals 38. So that's true. Left side equals right side. You can either write a check mark or left side equals right side is another way to write that. Okay, either or. We have to check it in both equations for it to be a solution, right? We know it could be on this line, but not that one. So in order to be the solution, the intersection point has to be on both. So does 11 equal 8 plus 3? Yes, sirree, Bob. Left side equals right side, and there's a solution, 11 and 8. All right, so what's great about this unit, in a lot of our questions, we're always going to be able to check our solution. If you check your solution and then you get it right, so nice when you get to truly check it very easily. All right, we're going to skip question 2. It's pretty much identical to what we just did. I'm on to this last one. Now, I'm going to show you a table that can be very helpful. You don't have to use a table to make an equation, but it is definitely optional, especially if you struggle with word problems. And this table can be used in value money questions. And there's a few different tables, and I'll show you by the end of the unit. Let's create a linear system to model this situation. In Calgary, a school raised $195 by collecting 3,000 items for recycling. The school received 5 cents for each pop and 20 cents for each plastic bottle. Now, we still have to figure out what are our two variables going to be. What are our two unknowns? What's the obvious question that would come from this? How many bottles and pop cans? So let's use those as our two variables. So which is our variable? So what do you want to do for pop can? P is the number of pop cans. And then for bottles will be a Q. I'm going to use B. Number of bottles. All we need is a J. Okay. Oh, my battery's dying. Okay, guys. Okay, so when we draw a chart, we have two situations, so you need two different rows for the two situations. And then you need a row for your total. It's going to look like this. It's almost like a 9 by 9, a 3 by 3, 9 squares. But your total goes right there. Okay? So it looks weird right now. Let me explain. So your two situations goes on the side. Our two situations are pop cans and bottles. Pop cans and bottles. Just add one. Okay? So the formula is this. We need to make an equation. Now in a total and a value, we have a value problem. The price for one times the number we have of that item equals the total value, the total amount of money for each item. So if I have a pop can worth 5 cents and I collect 100 of them, then 100 times 5 cents would be how much money I collected. So $5 in pop cans. So we're going to fill in this chart. Now, the pop cans, how many what's the value of one pop can? 5 cents. Now, if our units are not the same, we need to make them the same. So I'm going to keep it in dollars. So 0.05. What's the value of bottles? 0.20, 20 cents. Now, your variables are always going to go in these middle two boxes. So the number of pop cans we collected, we called it P. And the number of bottles we collected, we called that B. Okay? So it's just this is a tool to use to get the equation. Oh yeah, okay. All right, so then the total money collected in pop cans, if they're 5 cents each and I collected P pop cans, then the total number of money collected from pop cans would be 0.05p. These two multiplied together. And the total money collected in bottles would then be 0.20b. And last, we have our two totals to fill in. So the total number goes here, total number. What's the total number of items collected? 3,000 items were collected for recycling. And the total amount of money goes in the bottom. How much total money did we collect? 195. So our equations are going to be these two. Here's our first equation. Oh, that's no fun. Let's try that again. Uh-oh. Oh, now it disappeared. Thank you. Thank you, Magic Pen. Okay, so this is going to be one equation. Come on, Magic Pen. There you go. P plus B equals 3,000. That will be your first equation. And then your second equation would be this one. 0.05p plus 0.20b equals 195. I'm glad you like that. Okay, now, a lot of you probably could have come to this equation on your own. You don't have to use a table. It's optional. So how many items? Well, the number of pop cans plus the number of bottles equals 3,000 items. And then the money always goes together. So 0.05 cents times the number of pop cans plus 0.2 cents, or $0.20 actually, times the number of bottles equals $195. Notice how the money units will always all go together. And so you don't have to use a chart. You might be able to come to this without it. However, if you struggle with these word problems, chart might be useful. The last part says the school collected 2,700 pop cans and 300 bottles. Use the linear system to verify these numbers. So they give us the solution. What is P equal to? 2,700, and B was equal to 300. So let's verify that this is the solution. P plus B has to equal 3,000. So we plug the equation in. Does 2,700 plus 300 equal 3,000? Yes. So left side equals right side, or you can just go and check. If it doesn't equal, you have to for sure put that not equal to through all the equal signs. And then the last one, we need to plug that one in. So 5 cents each times 2,700 plus 20 cents each times 300 of those has to equal $195. So I believe this is 135 and this is 60, which gives us 195. Left side equals right side. So that is the solution. Okay? So turning the next page, the last question is if an equation is given, we have to be able to come up with the situation or the solution. Does everyone have this down? Not quite? Okay. So start reading the next question and see if you can figure out what I stands for and what R stands for. So the next problem says, a store sells wheels for roller skates in packages of 4 and wheels for inline skates in packages of 8. Create a situation about wheels that can be modeled by the linear system below. Explain the meaning of each variable and write a related problem. So the first thing we need to do is figure out what does I and R stand for. Please do not say I stands for inline skates. It has to be either the number of inline like wheels or the number of something. Like you can't just say I is inline skates. You have to be more descriptive. What about the inline skates does it stand for? The packages. The packages. Why is it the packages? Well, let's look at this. It says, do we know how many wheels are in each package? It says a store sells wheels for roller skates in packages of 4. Yeah, so we know the wheels in each package. What we don't know is how many packages we sold. We know how many are in each package, but not how many we sold. So what does I stand for then? The number of inline skate packages sold. We are able to just go L equals length before because length is an actual measurement, right? Inline skates isn't a measurement. Number of packages is. Okay, now R would then be number of roller skate packages sold. We know how many wheels are in each package. We don't know how many packages were sold. Do you see that 8 and that 4 in the equation somewhere? Yeah. Remember, 8 stands for wheels. 8 wheels and 4 wheels. So that first equation, if we have, let's talk ourselves through it and replace the variable with what we actually said it was stood for. So 8 wheels times the number of inline skate packages sold plus 4 wheels times the number of roller skate packages sold equals 440. So what does that 440 have to stand for? Total number of what? Packages or wheels? Wheels, because if we had 8 wheels times the number of those packages, 4 wheels times those packages, this also has to be wheels. And so the first equation would be that there was a total of 440 wheels sold. A total of 440 wheels sold. That's equation 1. Equation 2, how did they get I plus R equals 80? Let's read through it again. What does I stand for? Packages. So the number of inline packages plus the number of roller skate packages equals 80 packages, because it's all with packages. So there's a total of 80 packages sold of both inline and roller skates. That's basically all you need to do for a problem like that that's in your homework. Tell me what your variables stand for and basically write out each equation as a sentence. What would that sentence have to be in order to get that equation? No? Luke, do you have a question? You sure? All right, so your homework, we're done for today. Lots of time for homework. Your homework is on page 401. Should be really quick. Please do a good job. And I do want to give back your unit exams this class as well.